A good day to everyone. We are here to present to you our design and simulation of a two-stage transistor amplifier using LTSpice, presented by Group 2. These are the members of our group. And to begin with,
Abstract. This experiment's main goal was to build a two-stage transistor amplifier with a voltage gain of 300 volts or more. A transistor is an electronic device with three terminals and three semiconductor layers. Two-stage transistor amp computed value is 1227.23 and simulated value is 1428.2741. The bypass capacitor and resistance in the circuit allowed the amplifier to achieve higher voltage but with some distortion. The total values or voltage gain are calculated manually and are close to the simulated values. Introduction. Bipolar junction transistor or BJT is a three-terminal semiconductor device with three layers that have different degrees of doping in each of the three P and N layers. Bipolar junction transistor have three distinct sections, which is base, collector, and emitter. A transistor acts as an amplifier by combining weak and strong impulse, increasing the circuit's output power. The DC bias voltage ensures forward bias suppression of the emitter-base junction. A common emitter circuit with an unbypassed emitter resistor or RE. The current and voltage polarities shown correspond to the input voltage. Positively polarity, RE affects the circuit input impedance and voltage gain without a bypass capacitor. Multi-stage amplifiers use the output of one amplifier to drive multiple amplifiers in series. Its output is insufficient for many practical applications.
now to discuss our methodology, what we did is that we computed for the total voltage gain and we simulated it using LTSpice to get a clear depiction on the difference or similarities between the voltage gain of the computed and simulated. For the computation, we computed for the voltage gain one step at a time. For the two-stage transistor amplifier, we found out that the Rin base is so much more significant than the value of R2. Therefore, we can utilize the formulas and equation given in our ECE lecture. After getting the values needed, we plug it in our equation for AV. Our voltage gain for the first step is 24.428. Moving on to the second stage, we also did the same procedure as before, and we've come up with a voltage gain of 50.103 at the second stage, yes. The last thing to do is to multiply these voltage gains to get the total AV, which is 1227.423. Moving on to the simulation, the same idea applies here, wherein we get the same stage wherein we get each stage's voltage gain, then multiplying them to each other to get the total AV. By the way, we utilized AC sweeping for our schematics. We plotted V in and V out at the first stage to get the necessary values for the computation of voltage gain, which is 23.14. Doing the same for the second stage, and we get an AV of 61.722. Multiplying these voltage gains, we get the overall voltage gain for the simulated values to be 1428.2471. And now, to give you a demonstration on how our transistor works or amplifier works, we need to tick into LTSpice. So in here, for our project, we utilized an AC signal for V in, which has a value of 100 microvoltage or an amplitude of 100 micro. So if we using AC sweep and clicking on run, we need to first stick into V in and V out, and then change the representation of y-axis to linear, thus giving us this plot. So our V in has a value of 100 microvoltage, and our V out has a value of that peaks around 142 microvoltage, which indicates that there is a voltage gain in our two-stage transistor amplifier. Now, if we want to get the actual voltage gain of the amplifier, we need to plot each and compute for AV. So we need to do it one step at a time. Now, let us try to change our value of amplitude in AC signal to 10 microvolts. So if we plot V in and V out, changing this to linear, we can see that our voltage in has a value of 10 millivolts. But if we take into the V out, as we can see, it peaks around 14 volts, which indicates again that circuit is our circuit was able to amplify the voltage that is coming in. So if we want to get the voltage gain at each, we need to do the same procedure as the last time, wherein we get the voltage gain one stage at a time.
Now, for the results and discussion, I will be discussing the acquired values for our two-stage amplifier, specifically a common emitter amplifier. One of the requirements for a two-stage amplifier is to have a voltage gain of at least 300 or more. For our proposed circuit, it produced a total voltage gain of 1428.2471 during the LTSpice simulation. Meanwhile, we computed a total voltage gain of 1227.423 for our manual computation. Our group believed that the discrepancy between the simulated and computed values is caused by the beta value of 2N3904 BJT transistor. The discrepancy occurred because our group used the transistor's approximate maximum beta value of 300, and as we know, using rounded off values could affect the total voltage gain in the manual computations. Now, for this two-stage amplifier, it has two BJT transistors, and both are NPN transistor with three terminals such as base, collector, and emitter. For the first stage of the transistor amplifier, the Rn base value has a value greater than 10 times the emitter resistance, which is why we use the equation VB1 is equal to R2 over R2 plus R1 times VCC, which produce a value of 2 volts. Now, using this value, we also computed for the values of VE, IE, and IC, which are 1.3 volts, 0.867 milliamps, 0.867 milliamps, respectively. Meanwhile, the value of IB is calculated using the equation IB is equal to IE over BDC, which produces a value of 3.38 microampere. On the other hand, the AC emitter resistance or R prime was solved using the equation R prime is equal to 25 millivolts over IE and has a value of 28.835 ohms. So, after getting these values, we proceed in getting the voltage gain using the equation AV1 is equal to RC parallel to RL all over IE. So first, we computed the values of RC and RL, then we substitute it together with the value of IE. So, For the first stage, we computed a voltage gain value of 24.498. Now, for the second stage, the process is just the same with the first stage. For VB2, we have computed a value of 1.714 volts. And now for VE, it has a value of 1.014 volts. And for IE and IC, they have the same value of 1.014 milliamps. For IB, a value of 3.38 milliamps, and for RE prime, a value of 24.655 ohms. Now for the voltage gain value, we computed a value of 50.104 for the second stage. Furthermore, using the equation AV total is equal to AV1 times AV2, the computed total voltage gain for our amplifier is 1227.423. Now, for the simulation in LTSpice, the equation we use is AV is equal to V out over V in. For the setup, our group used AC analysis in LTSpice with an amplitude of 100 microvolts AC and a frequency of 1K. So based on the results, the voltage output of the first stage in the simulation has a value of 2.314 millivolts. Since the voltage output of the first stage is the voltage input of the second stage, the values would be the same. However, the voltage output of the second stage is 142.824 millivolts. So from here, the values obtained in the simulation produce a voltage gain of 23.14 and 61.722 respectively. Meanwhile, the total voltage gain in the simulation is 1428.2471. So, in addition, we believe that the bypass capacitor and resistance of the circuit allowed the amplifier to achieve a higher voltage, although there are some distortion. So, to counter this, the voltage divider settings should be large enough to offset this effect. After doing this simulation, we learned that in order to avoid distortion while still being able to obtain the desired voltage gain, balancing the settings for the bypass capacitor and voltage dividers would be critical in the design of a two-stage amplifier.
For our conclusion, BJT amplifiers are often used in generating high voltage output from a small signal source. In addition, its configuration is simple and gives off the highest voltage gain for a given load. And in this project, the researchers are tasked to design a two-stage amplifier which are able to generate a voltage gain of more than 300. To be able to have a voltage gain of more than 300, the researchers have used the BJT common emitter amplifier transfiguration. However, one-stage BJT amplifier would not be enough to generate the desired voltage gain. Therefore, addition of another one-stage amplifier is necessary. In this study, the researchers have performed actual computations and simulations using LTSpice, and the manual computed values for the total voltage gain are relatively close to the simulated ones. And the designed circuit was able to generate more than 300. To be more exact, the manual computed voltage gain was 1227, while the simulated voltage gain was 1428. That's all.